Alright, we're going to be continuing with the 2017 release test for the STAAR. We're starting with question number 11, second video. So it says, what's the solution to 8x minus 3, open parentheses, 2x minus 4, close parentheses, equals all this? We're basically solving for x. Now we're going to do it by hand, and we're going to do it in the graphing calculator. So the first thing you would have to do if you were to do it by hand is distribute. So that leaves you with 8x minus 6x plus 12 equals 3x minus 18. Whenever you're solving for x, you have to get all the x's to one side of the equal sign, and all the coefficients or constants, or the numbers, on the other side. So we can combine these. These are like terms. 8x minus 6x is a total of 2x. Alright. Okay. Now can't combine those, so now we have to make a decision. Where do we want to put them? On the left side or the right side? Well, I'm going to choose everything going on the right side, the x's. So minus 2x here, minus 2x here, and that zeroes out. Those are called additive inverses. They zero out. So let's see what we have left now. We have 12 equals 3x minus 2x is x minus 18. We're almost there. Okay. Oh, my son is saying add 18 to both sides. So I'm going to go ahead and do it. Add 18 to this side and add 18 to this side. So we have a total of x equals 30. Okay? Now that's how you would do it by hand. But if you have a graphing calculator, you can actually take all of this and put it in y1 and put all of this in y2. So watch how I do that. Here we go. So I'm going to hit y equals. So we turn, if you're at this screen, you hit y equals. And then go over here. So I'm going to go over to here. I'm going to 8x minus, here we go. 8x minus 3, open parentheses, 2x minus 4. And you do have to type in everything perfectly accurate. Alright? Otherwise it won't work. Over here, you're going to type 3, open parentheses, 3 times the difference of x, 6. That. Now, wherever these two lines meet, that's going to be your answer. So check this out. When I hit second graph, what we're looking for is we're looking for where the y values are the same. And we got the answer of 30. So here's how you can check your answers. All right? So watch this. I'm going to check 6. I'm going to check 2. I'm going to check 30. That's going to be our answer. So here's how you do it. You hit second window. You check 6. Do these numbers match? Nope. Second window, you check 2. Second graph, do those numbers match? Nope. Second window, check 30. Those numbers match. That means you found the right answer. So, that right there, if you're using the graphing calculator because you were just not very good at solving for x by hand, that's how you could get to your solution. What are you going to do? Put that in y1. Put this in y2, and then check your table. Okay? If you can check your table, you can get the right answer. All right. Done with that one? Moving on. There's x30. That's our answer. Moving on to number. Oh, next page. Oh, got to zoom out. There we go. Let's take a look at this one. All right, here we go. Lifeguard earns $320 per week for working 40 hours, plus $12 per hour worked over 40 hours. All right, a lifeguard can work a maximum of 60 hours per week. Which graph best represents the lifeguard's weekly earnings in dollars for working H hours over 40? So we got to figure out which one of these graphs matches this situation. So we're going to have to take a look at it, and we're going to write down what our function looks like. Okay, so what we're going to be looking at, we're going to be writing an equation. Okay, so right now we have H equals hours. Okay, and I'll just put D equals right here. I'll put W right here for the weekly earnings. That's the money. Do a better dollar sign there. There we go. Weekly earnings. Weekly money. Alright, so if we're going to make a table for H and W. These are the hours that he's going to be working, specifically the hours that are over 40. Now he's going to start with what? $320 per week, all right? So his weekly earnings, it's going to start at $320, but he's going to make $12 per every hour over 40 hours. This only is going to work for H is greater than 40, okay? Greater than 40 hours. Now, right now, where is he starting at? 320. So right now, the first thing you would look at is look at all the graphs that start at 320. Okay, does that graph start at 320? No. Does that graph start at 320? No. Does that graph start at 320? I would say so. And does that graph right there start at 320? Absolutely. Okay? So now let's kind of figure out, in slope-intercept form, we would write W equals 12H plus 320. So let's think about this. Ready? At 0 hours of overtime, he still makes $320. At 1 hour of overtime, you're going to add 12 to that. So what's that going to put you if you add 12 to it? 332. Okay? Let's go into our user graphing calculator. Let's check it out. Okay? So again, y equals. Go up here, type in 12x plus 320. So we're using terms of y and x. All right, and let's check our table here. Let's start at 0. Okay, so at 0 we're at 320. Then we're at 332, 344, 356. So it's going up like that. So we're trying to find the graph that matches this. Let's go back to our graph. Let's take a look at this. Okay, so right now at 20 hours, at 20 hours overtime, that puts you right up here. Whereas in 20, where's the other one? 20 hours overtime puts you right here. All right, so let's check 20. Let's see which one works. Let's go to 20. Second window, type in a 20. Ooh, 560. 560. So which one best represents when the number of hours is 20, it's at 560. That doesn't get to 560, that one does. So the answer would be G. Now why does it stop right there at 20? It stops at 20 because it says the maximum hours is 60. So if you've already worked 40 hours, the maximum you can make is 20 more for a total of 60 hours. That's why you have the dot right here ending at 20. Just remember, everybody, this is your domain, and the money is your range. Okay? Answer 12 is G. We're going to go to the next page. Here we go. Let's look at this. Number 13. Zoom in just a bit. I might be able to see. There we go. It says a shoe company is going to close one of its 2 stores on that, and combine all the inventory from both stores. These polynomials represent the inventory. It says which expression has the combined inventory. So what do you think combined is? Yeah, put together. So we gotta add these together. So basically all you gotta do is add like terms. Okay? So we're gonna take 1 half G squared plus 7 over 2. Alright, we gotta combine it with the other one, which is 3G squared minus 4 over 5G plus 1 4. So we got to search for terms that are exactly alike. So G squares can only be added to other G squares. Okay? So if you were to add these together, that's a half, that's a 3. Alright, hopefully you know when you add those together that becomes 3 and a half G squared. But you'll notice none of these answers have what? 3 and a half. So we got to make this into an improper fraction. Okay? So how do you do that? Go back to elementary school, we multiply those together, and we add this together. 3 times 2 is 6 plus 1 is 7. There we go. Now, let's look at the G's here. See any other G's in that equation? I don't see any other G's, do I? So what do? Just bring it down. And what's the only only other thing that we have to combine, we got to combine what? 7 over 2 plus 1 over 4. Now, if you're going to do this by hand, yes, you would have to find a common what? Common denominator, okay? So what would I have to do? I'd have to make this denominator right here equal to a 4. Now that's already what? A 4, right? So that multiplies by 2, so multiply that by 2, that gets us. Then we can add the numerators together. That's it, 15 over 4. Then we look for the answer. 7 over 2g squared minus 4 over 5g, 4/5 of g plus. Looks like it's answer choice A. Now for those of you who are like, you know what, I'm just not good at adding fractions together. Here's what you can do, check it out. Get your calculator. Do 7 divided by 2 plus 1 divided by 4. Hit the math button. You press enter twice. And look what the calculator does for you. I'll do it one more time. 7 divided by 2 plus 1 divided by 4. Then I said hit the math button, and we're going to change everything to a fraction. And voila, there it is. Alright, so that's answer choice A. Okay, let's go down to man, next page. They really like to use lots of pages here. Okay, here we go. Okay. Let's see what this asks us to find. Here we go. It says the graph of a quadratic function is shown on the grid. What is the y-intercept of the graph of f? I love it. Love it. Y-intercept. What does the y-intercept mean? Wherever the graph touches the line. Boom. That's it. Where is it on the y-axis? 4. Okay? Now, listen up. We're going to name some things here. Alright? We're going to use this to help you guys name some stuff. Okay? So your y-intercept is at 0, 4. That's the y-intercept. Okay? Now, it says, what is the y-intercept? Record your answer and fill in the bubbles. You would actually put the number 4 as the answer and fill in the bubbles. That's what the bubble answer would be the number 4. But we're going to talk about some other things. Like, do you know what this point right here represents and that point right there represents? Those are not y-intercepts. Those are actually called X-intercepts. Okay? Now, X-intercepts are also known as zeros, solutions, or also known as roots. These all mean the same thing. So this has 2 solutions, okay? Now, there's another thing you need to know about this parabola. This point right here, that's the lowest point. That is called the vertex of the parabola. And this vertex is also referred to as its minimum. Why is it called its minimum? Because it's its lowest point, okay? Now, one more thing I'm going to tell you guys. I'm going to tell you guys what the domain and range are. No, I just lied back, so I'm going to tell you 3 things. I'm going to tell you the domain, and tell you the range. The domain for all parabolas will always be all real numbers. So if it says, what's the domain? You would say all real numbers. But if it says, what's the range of this? What's its lowest point? -5. All of my values, are they getting bigger than a -5 or are they getting smaller? All of my y values are getting bigger. So my range is y is greater than or equal to -5. That would be the range. So they could ask you a whole bunch of stuff about parabolas. They could ask you about zeros, which are these. They could ask you about the y-intercept. They could ask you about the vertex. They could say, what's the y-coordinate of the vertex? You'd say -5. Or what's the x-coordinate of the vertex? You'd say -3. The last thing I want you to do is this. The last thing is, I'm going to draw a line straight through that parabola. Now that line has a specific name. Do you know the name of this line right here? It splits it perfectly in half. That is called the axis of symmetry. That's right, the axis of symmetry. Alright, and the axis of symmetry in this particular case, what is x always equal to on this line right there? What's my x value always equal to? -3, you're right. You said -3, you're right. That's vertical lines always are x equals. Horizontal lines are always y equals. That's something you need to know. So even though, technically, all you needed to know in this particular problem was what? That the y-intercept was at a 4. Now you know a whole bunch more about this parabola, if you can. All right, moving on. Ooh, look at this one. All right, here we go. Number 15. A particular type of cell doubles in number every hour. Which function can we use to find the number of cells present at the end of h hours if there are initially 4 cells? Okay? So here we go. What are we starting with? We have h hours, right? We have the number of cells. So after 0 hours, what are we starting with? We're starting initially with 4. But after 1 hour, it says it's going to do what? Double. What are we up to? 8, yeah. All right, after 2 hours, it's going to double. Man, after 3 hours, it's going to double. Oh, we got to double that. 32. Then after 4 hours, we're going to stop at this, right? 64. We won't go on to 128 or 256. Let's keep on stuff right now. So you got to figure out which one is. Now, by the way, whenever you see functions like this, just know that this equals y and this equals x. This equals y and this equals x. This equals y. This equals x. This equals y. This equals x. Why is that important? Because I want you guys to be able to use your calculator. And y equals. All right, so we're going to figure out which one of these works, okay? Now, by the way, if it says doubles, which one do you think we're going to probably mark off that we probably wouldn't use? Which answer do you think is like not? Which one? Doubles means what? 2 times, right? So what does that say? Yeah, we're not going to do A because that says half, multiply by half, right? So what else would we not probably use? D, right? Okay, so now we got to go either this one or this one. It's either B or C. Let's check B. We're trying to make this table, right? Here we go. So I'm going to put y equals 4 parentheses 2 to the power of x. Let's check the table. Oh, let's start at 0 though. Second window, we're going to start at 0, not 20. Okay, here we go. Start out to 4, then it goes to 8, then it goes to 16, then it goes to 32, then it goes to 64. What's happening every single hour? What does it look like it's happening every single hour? Double. Okay? Well, that ends up, by the way, that ends up being our answer. Okay? Well, let's look at the incorrect answer. Let me show you how this answer is incorrect. Okay? So here we go. I'm going to go to y2. I'm going to use 4 plus 2 to the power of x. Let's check this one out. At 0 hours, where do we start at? Wait a second. So it's already gone up, and we haven't even started the timer yet. Okay? Does that double right there? No, that doesn't double. Does that double right there? No. And does that double? No. What's the only one that's doubling? This one. So what can you do in these type of problems? Just hit y equals and do what? Plug it in and then check your what? Plug it in and check your table. It's as easy as that. Okay, let's go on. Oh, right, it says go on. We're going to continue to go on. All right, here we go. Aha! What is the slope of the line represented by 5x minus 12y equals 24? By the way, this is not in slope-intercept form. This is what's called standard form. Okay? So that's standard form. So write that down. Ax plus by equals, c. Not 24. Right, this is in standard form. Now what we have to change it to, we're going to change it to y equals mx plus b. So we're going to do it by hand. Okay. Whenever you're changing to y equals mx plus b, basically this is what you're doing. You're solving for y. That's what you're going to do. You're going to solve for y. So right now, if we were going to solve for y, do we have y all by itself? No, we got this pesky 5x. How could you totally get rid of 5x? Like make it equal to 0? What did you do? That's right, minus 5x. We're going to minus 5x from this side, and we're going to minus 5x from this side. Now, I'm going to bring this down. You have 12y equals. Now you can't combine those. The reason you can't combine them is because they're not like terms. That's a 24, that's a constant. That's a monomial, which means it has a variable attached to it. So all I'm going to do is I'm going to bring it down. I'm going to bring down the negative 5x, and I'm going to bring down the 24. Okay? I'm going to bring down the plus 24. So what am I going to need to do now? I don't want to know what negative 12y is. I want to know what y equals. So now what I have to do is I have to divide and divide and divide everything by whatever number's in front of the y. What number's in front of the y? Well, more specifically, so I got to divide by a negative. Divide by a negative. Divide by a negative. Okay? So negative 12, they cancel out. Negative divided by a negative is a positive, so that's 5 over 12. And 24 divided by negative 12 is a minus 2. Now this answer is in slope-intercept form. Just remember, in slope-intercept form, the n value represents your slope, and the b value represents your y-intercept. So if I say, what's your slope? What's your n value? It's going to be 5 over 12. Well, what's your b value? That's actually a negative 2. So it says, hey, look what the answer is. Well, the answer is a negative 2. That's your y-intercept. This answer represents your slope. So you see how these two answers, those are, that has something in the equation. That has something in the equation. That's what we're looking for because it says, what's the slope? Now let me show you how you can use Desmos on this. I don't know if this would be helpful. So we're going to use Desmos, which you can use. You can use the test mode. So it says 5x minus 12y equals 24. So I'm going to go over here to Desmos. Okay, I'm going to delete that. Okay, it says, what was the equation again? Look at it. Is it 5x minus 12y, 12y equals 24? Okay, now do you see this right here? That's your y-intercept, okay? But I'm going to zoom in a little bit. It's kind of hard to see your slope because what was the slope? The slope was 5 over 12. So here's what you would have to know. You'd have to okay, well, how do I figure this out? That means it has to go from here. It has to go up 5 units. Up 1, 2, 3, 4, 5. And it has to go over how many units? 12. I don't know if you can see that slope. That's, what do we call this section in the graph right here? We call this section the rise. We call this section the run. So the rise is 5 because it goes up. And the run is equal to 12 before it hits this point right here. So where did it start? It started there. So you could use Desmos, even if you're like, okay, I'm not sure what did you use? You could count up and count over. And what does that help you do? It helps you eliminate. By the way, if it's going up from left to right, what does that tell you about the slope? It has to be positive. So by just typing in Desmos, what do you know about the slope? You know the slope is positive. Let's go back and take a look at the answers. What does that say? Negative. What does that say? Negative. What would this slope mean? It means it would go up 24 and over 5. So just by looking at it, can you tell how this does not go up 24 and over 5? So you can just use Desmos and pretty much get the answer by using one thing that you're going to need on this test. Logic. You need some logic. Okay? So make sure, before you take this test, bring this with you. Okay? Alright. Moving on. Which expression is equivalent to this? No. You know what? I don't. You know what? This is, Fun Fact and Friday is definitely it. Okay? But what we're going to do is we're going to show you how to use the graphing calculator to show you how easy it is if you don't know how to factor. So right here, here's what I want you to hit y equals. Clear this out. Clear this out. You're going to type in, so hit y equals 6x squared. Okay? Oh, hold on. I'm going to take a screenshot of this. Get back. There we go. Take a screenshot. Okay, 6x squared plus 13x plus 5. Here we go. 6x squared plus 13x See that right there? That's the graph. So hit y equals and type that in. Hit y equals, type that in, hit graph. Now, let me show you kind of a cool little trick that you can do. Alright? You see how that's a positive and that's a positive? That means your factors all have to be positive. Okay? Which means you're not going to use A, you're not going to use B, and you're not going to use D. But I mean that's kind of that's one of those rules you have to know. If everything's positive, then you know all of these factors also have to be positive. But let's just type it in. 2x plus 1, 3x plus 5. Right, here we go. So y equals, we're going to go down here, we're going to open parentheses, we're going to go 2x plus 1, okay? And then we're going to go, was it 3x plus 5? 3x plus 5, okay? Now, if these are the same, okay? If this is the same as this, I'm going to hit graph. What did you see happen? It went over it, which means, what does that mean? That means these right here, there's 6 right there. These right here are the same. Okay? So those are the same. Now, here's how I would like you to be able to do it by hand. You have to know how to do the FOIL method. Okay? Now, if you have 6x squared, okay, they already told you the first two factors were a 2x and a 3x. But if you want to be able to factor this, the most important is the outside terms and the inside terms. Because in the FOIL method, first, outside, inside, last. I'm doing the FOIL method. Okay? The first term is 2x times 3x, which is 6x squared. That's easy. Okay? The last terms have to be equal to a 5. So what's going to go there? Either a 1's going to go here and a 5 is going to go here, or a 5 is going to go here and a 1's going to go here. But what you really have to check is not your first and your last. So this one really, when you're factoring, I'm not really worried about my first and my last one. I'm worried about is my outside and my inside terms adding up to 13x. That's what I'm worried about. So 2x times 5, 2x times 5 is 10x, and 1 times 3x is 3x. And what do those add up to equal? Those add up to equal 13x. That's why these are considered to be what's called the factors. Okay? Now, sometimes, all right? Sometimes I'm just going to go ahead and make a square. Okay? So sometimes students like to use this to check their factors. Okay? So you can make a square. Okay? And on one side you could put a 2x and a 1, and over here you could put a 3x and a 1. Okay? And then what you're going to be doing is just be multiplying together and see if you get those up to 13x. So here's another way of doing it. 2x times 3x is 6x squared. 2x times 1 right there is... Oh wait, I messed up here. Hold on, it's supposed to be 5. Not a 1. My apologies. There we go. All right. So I have 2x times 5, which is a total of 10x. 3x times 1 is 3x, and 5 times 1 is 5. Okay? So what can you add together right there? You can add those together, and you get a total of what? 13 x's. Okay? So that lets you know the answer C. But if you didn't know how to do all that, what could you do? Put that in what? Put that in y1, and then put this one in y2, and look to see if it does what? Let's see if it traces, which is right here. One graph traced over the other. All right, on to number 18. All right, so here we go. Number 18 is a system of equations. It says a bus travels 2 different routes, the green route and the blue route. So what I'm going to do, I'm going to call this one G. I'm going to call this one B. All right? So it says, on Monday, the bus traveled the green route 6 times, which means you got 6G. And then it traveled the blue route 5 times. So I'm going to put 5G. And what's the total miles that it traveled? It traveled the total miles of 52. Okay. The next one, on Tuesday, the green route happened 12 times. And then the blue route happened 13 times. For a total of how many miles? 119 miles. Okay? So if you ever have a system of equations, okay, you can use the elimination method, you can use the substitution method. I prefer the elimination method. It says, what is the length of the what? Green route. So if we're trying to find the, what did I mess up? I apologize. Sorry, yeah. Should have put it. There we go. So what we're going to do is it says, what is the length of the green route? So what I'm going to do is I'm going to eliminate the blue. Okay? I'm going to eliminate the blue. I'm going to solve for the green. So how would I do that? Here we go. I'm going to take the top equation and multiply it by something, and the bottom equation and multiply it by something. I'm going to take the top equation. I'm going to multiply everything by a negative 13. I'm going to take the bottom equation and multiply everything by a 5. So what we have to do is distribute, 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 distribute. Okay? Since we're graphing calculator, it can come in handy. So negative 13 times 6 is negative 78G. Negative 13 times 5 is a negative 65. This is a B. Equals. And negative 13 times 52, well, I'm just going to go ahead and negative 13 times 52. All right, what do we get? Negative 676. Okay? Now, we're going to distribute this 5 to everything. What's 5 times 12? That gets us 60. 5 times 13 gets us to positive 65. Okay, and then 5 times 119 equals 595. Okay, here we go. Now we got to add like terms. What happens right here? What happens to all these? They cancel to 0. We're going to add these together. That gets us negative 18 G's. Okay, equal. We have negative 676 plus 595. Negative 676 plus 595 gets us negative 81. Okay, so go back over here. Negative 81. And so what's our last step? Negative 18G equals negative 81. What are we going to divide both sides by? Negative 18. So we're going to do negative 81 divided by negative 18 equals 4.5. So what's the green bus equal? 4.5, which is answer choice G. Man, I wish there was a heck of a lot easier way to do it. There is. But you have to know the matrices. Are you allowed to use the matrices? Absolutely. So check this out. You guys are going to be like, what? My algebra teacher didn't show me this? Here we go. So you're going to make a little graphic. Okay? You're going to put a 6, a 5, and a 52. And you're going to put a 12, a 13, and a 119, just like that. Now, in the matrices, there are 2 rows and 3 columns. You're going to make it 2 by 3. All right? So if you write that down real quick, 6, 5, 52, 12, 13, 119. You're going to make it 2 by 3. So check this out. Second matrix, we're going to go over to where it says edit. We're going to edit A. And we're going to make it 2 by 3. All right? And I'm going to get all these deleted out. So we got a 6, 5, 52. 6, 5, 52. Okay? And then over here, we got a 12, 13. Right? 12, 13, and then was it 119? Yeah. 119. Okay? Now this is where you're going to have to know how to use the graphing calculator, because this right here is in the matrix. Now check this out. You got to find what's called the reduced row echelon form. And you're like, what the heck is that? Well, you don't have to know what it is for you to use some math might be angry at me. But watch this. Second matrix, I'm going to go to math up to where it says RREF, reduced row echelon form. Now I want the reduced row echelon form for matrix A. Oh, this is awesome. Okay, what does that say? 4.5. Alright, what does that mean? That means this is right here. If you go back and look at your problem, that represents what? G. That represents B. So G is 4.5 and B is 5. Now if you really want to know how to do it, you could rewind the video and watch that over and over and over again and know how to get things in the form of a matrix and do what? Reduced row echelon form. Man, that was hard. Not really. Okay. Here we go. It says the table shows the heights and lengths of several rectangles. Man, this video's getting long. We're only do 2 more problems and we're done. Okay? What does the correlation coefficient for the data indicate about the strength of the linear association between the height and the length of these rectangles? What? Correlation coefficient, what does that mean? So we're going to use the stat editor. So we're going to put that in L1, we're going to put that in L2. So we got to get our stat editor out, and we're going to take a look at this, and we're going to find the correlation coefficient. Okay? All right, here we go. So I'm going to go stat enter. If you have stuff in here, I got to delete this stuff out right here. Got to delete this stuff out right over here. Okay, here we go. So help me out. Tell me the L1 column. You got to get those numbers right. Okay, go ahead. 41. Stat. Okay, here we go. So we got 41. Then we got 70. Then 21. 34. 10. 92. I'm typing all these in just looking at my paper. Should have written those down. Follow along if you need to. Rewind the video. 24, 10, 35, 42, and 66. Alright, now we got to go over here to the right. And 41 goes with a 21. We got a 25 and a 32. Then we have a 12 and 16. Then we have a 45 and a 40. Then we have a 23 and 45. Oh. Alright, then we have a 35 and a 21. Hopefully I only have one more. 14. Alright. Now, very important. These are your X values. These are your Y values. What I'm going to do, okay, as I'm going to look, I'm going to scan our X values and Y values. What's the smallest X value? What do we have? What's the smallest X value? Looks like it's a 10, right? Smallest X value. What's the biggest X value? What's our biggest? 92. So here's what I want you to go to Window. Go from 0 to 100. 0 to 100, we're going to do an X scale of 10. Okay? Then we're going to hit Stat, Edit, and look at our Y values. So Y values, what's our smallest Y value? Is it 12? I think it's 12. Okay, what's our biggest Y value? 5. 45? Okay, so here's for the window. For the window, start at 0. Right here, go all the way to 50. Let's count up by 5s. So when we hit graph, hold on, let me clear this out. When you hit graph, now what I've done in my graphing calculator is I started at 0. For the x's, I've gone to what? 100, and for my y values, I've gone to a 50. Now what we're going to do is we're going to turn our stat plot on. So check it out. In second y equals, I'm going to turn my stat plot from off to on. Alright? And look at the graph. Whoa! Man, those numbers look like a shotgun. I don't see any correlation over there. correlation, the answer would be 1. So we're going to look at, all right, stat, right arrow, we're going to interpret this line. I don't know if that's going to be a line. So that's what it's saying, that's the line, okay? So look what happens. So we're going to hit stat, right arrow, go down to number 4, except we're going to store it. We're going to store this regression equation in y1, so you have to hit alpha trace, enter. Alright, so there, you hit y equals, you'll see that's in there. Now look what I graph. That line is pretty much the closest line that it can get to all of those points. But what does the question ask you? It says, what is the correlation coefficient for the data indicate about the strength of the linear association between the height and the length? What would you guys say? Do you think there's a strong correlation that those match or a weak correlation? What do you think? That's totally weak. Okay? But now how would you find the correlation coefficient? Okay? So here's how you would find it. Okay, let's go ahead. I'm going to go to my graphing calculator. Okay, I'm going to go to mode. Okay? I'm going to go down here to where it says stat diagnostics off. I'm going to turn them to on. Okay, turn them to on. So now I'm going to hit stat, right arrow, number 4, go all the way down. Okay. Now, right here, these are our correlation coefficient. Now, what is this equal to? It's equal to what? 0.15. In order for it to be a strong correlation, that would need to be really, 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 really close to a 1. That's what it's letting you know. So the answer to this particular problem, it says, hey, this is a weak positive correlation. Why is it a weak positive correlation? Because what's that number? That number is positive. Okay? So that would be the answer to number 19. Now, if you're wondering what a strong correlation would be, a strong correlation would be if and only if that these points right here were really what? Really close to the line, and some of the points were actually on the line. That's a strong correlation. Okay? A weak correlation is when these points are not close to the line. Okay? And why is it positive? Because what's happening with this graph? It's going up from left to right. What would be a negative correlation if it was going down from left to right? Okay? Alright, that was a big problem. One more problem, we're done. Hopefully it's a fast one. Oh sweet, it is. Super fast. It's like, that one was a long one, this is a short one. It says, the expression x to the third times x to the negative 17 is equivalent to x to the n. What is the value of n? By the way, this is called the product property in the law of exponential product property. Alright, this would be a totally non-calculator question. This would be totally like on a TSI, ACT, SAT. What are you allowed to do with exponents when you have the same base? What are you allowed to do with those exponents? You're allowed to do what with them? Yes. Add them together. So check it out. We have x to the power of what? 3 plus x to the power of negative 17. What are we going to do with these exponents? We're going to simply, oh, hold on. Those would be times. What are we allowed to do with those? Add those together. And what is the sum of 3 and negative 17? Negative 14. So what would you bubble in on your answer choice? You would bubble in a what? A negative and a 14. That's what your answer would be. Negative 14. That's called the product property. You're allowed to add those together if they're being multiplied. Don't be confused with the power property. So this is the last thing I'm going to talk about. There's so many things to talk about. Alright, here's the power property. When you have x to the 4 times to the power of 2, that becomes x to the 8. But if you have x to the 4 times x to the 2, that's where you take those and you add them together to get x to the 6. This is called the power property where you multiply. This is called the product property. So look at the difference between the power and the product property. What do you do with those? You add them. What do you do with these? You